Hi, in this video, we're going to talk about duck typing. And as this kind of little cartoon here depicted that for those of you who know another strongly typed language, such as C++ or Java, put on your seatbelts because you're going to be in for a wild ride. So we are going to start with kind of a theoretical question, and how does a Python interpreter works, right? And that's especially when it encounters code like this, where it tries to add two lists together, or tries to add two vectors together. I mean, how does the Python interpreter know that it actually can call list.dunderadd and vector.dunderadd in these cases? Now, there are several approaches that the Python interpreter can take. We're going to talk about one of them first, and that is it can keep a list of the types that actually defines the dunderadd method, and then when it's trying to decide if it can call the dunderadd method given a particular instance, it will look, oh, is that instance belong to one of the types in the list. So in other words, it can do something like this, and I'm actually writing out this approach in Python code. So we're going to define a method that's named, okay, decide if we can call the dunderadd method given an instance of something, right? And we have all the types that defines the dunderadd method. And in this case, in our little world, those types include the list and vector, right? Because, well, for list and vector, we define both of them. We define the dunderadd method. So, we are going to iterate through each of the element in this list. Well, this is actually a tuple. So, in any case, we're going to go through all the types in this tuple, and we check that the given instance or the given object, if it's in an instance of the type in this list, then that means this object actually has the dunderadd method defined, and in that case, we can call the dunderadd method by returning true. Otherwise, if we go through everything and the instance is not one of the types in this list that has the dunderadd method defined, then we return false. And I highlighted the instance check here because that one is checking the type of a given object. So the question is this a good approach? Well, since it took me so much time to explain that, the answer is probably no. This approach is not good, and the main reason that this approach is not good is that the list of types that define the dunderadd method, it's probably pretty long, and also it's going to keep changing because we're probably going to define more and more types over time that will define the dunderadd method. So this is not scalable, right? So, and also, this approach is really unnecessary. So what is a better way to do this? Well, the better way, and some of you might have thought of this already, is that when the interpreter tries to see if it can call the dunderadd method given an object, it can simply check, okay, does the object has a dunderadd method defined first? And if it has it, then it can call it, right? So in other words, another way to write this can call add method given an instance is that it can see if it has that method, this instance has a given method. And as a matter of fact, to check if an object or an instance has a particular method or attribute defined, Python provides a built-in method called hasAttribute. Okay, hasAttribute, right? And you basically just give it the name of the attribute or method that you're looking for, and it will tell you is it true If it has it, then it returns true. If it doesn't have it, then it returns false. And if it has the dunder add, then we can call the dunder add method. Now, just as a side note, for those of you who can see it, we can simply write this method as just return if it has the attribute dunder add. But some of you might be more comfortable if I write it out in the longer form. So between these two approaches, what is the main difference? Well, as you see in the parts that I highlighted here, that the first approach, it checks for the type of the given instance. And if it is the right type, then it is good to go. Whereas the second approach, it checks for if the given instance has a certain method. And if it has that method, then it can do something. And in that case, it doesn't really matter what the type is, right? So, and this second approach, I hope you can see that it can support a large number of types, and it can also support new types as they are added without having to make any changes to it. And it's no surprise that the Python interpreter would choose the second approach. So, and this is in fact generally true for Python, that its way of checking for types is not to check for type at all, but just to check what it can do. So not checking for type and checking what it can do is what's called a duck typing. So, and it got its name from this very kind of, I guess, famous quote that if it walks like a duck and if it quacks like a duck, then it's a duck, right? It doesn't matter if it's actually a duck, as long as it does what a duck should do. Although there's some contention to how accurate this statement is, but we'll get to that later. Now, duck typing is in fact a very natural part of Python, because Python, as we kind of know, that it's what's called a dynamically typed language, or late binding language. You might not have heard of late binding, but what that means is that for a name or for a variable, we can assign it to an integer at one point, and we can assign it to a different type at a later point, such as a string. So A by itself, in this case, is just a name, and it has no type information. So that's what that's referred to as the dynamically typed part. Okay, and now the type of A, it will eventually have type information when the code is executed, or at what's called runtime, right? And not when we write it, or compile time. So because runtime happens a lot later, quote unquote, and that's why it's also called a late binding language. And the way this works also, as we shall see, also makes polymorphism a very natural part of the runtime system. And this is in contrast to some other languages such as C++ or Java. They are what's called statically typed languages, or early binding languages, right? That means when you declare a name or a variable, you have to at the time you write the code, to tell the compiler what type it is, right? So if you say A is an integer, then you cannot at a later time assign a string to an A, because that's the wrong type. And that type language, again, it is determined when the code is compiled. So that is why it's called statically typed. It doesn't change, and it's also earlier than when you run the code. So I guess that's why it's called early binding. Now, it's worth pointing out that both C++ and Java do support polymorphism, and that's why I say here it's sort of statically typed language, because it actually can a variable can in some limited fashion be assigned a type, something of a quote unquote different type. So, and the types can actually be determined, and they are actually determined at runtime as well. But the rules that they can do that, it's quite strict. It's not as relaxed as Python's rules are.